from years 3 to 4, 2003 to 2004, the salary in 2004 was $1.355 million. That's an increase from 1274 of $81,000. So they're still getting raises, but look what's happening to these raises. That they only went up by $81,000 in 1 year. And oh, sorry, I looked at the wrong values. This 81 should be here. And from 1274 minus 1153 would give me a change of 121. So this value here should be 121. 121 per 1 year. Similarly, we would go down the line and we would get $41,000 per year from 2004 to 2005, and only a salary increase of $1,000 from 2005 to 2006. Okay, well, let's now look at what model these outputs are generated by. The model is the average salary equals negative 20 times the year squared plus 221 times the year plus $791. Okay, so we notice a couple of similarities. Number one, we notice that the initial value is 791. So we can say that the initial value is the 0.0791. This means that in 2000, the average salary was $791,000. Okay, well, we talked kind of about this 221. If it were just a linear function and all we had was the 221t plus 791, the 221 would represent the constant rate of change. But in this scenario, this is kind of just only the initial rate of change. It's only the blast-off speed. So we would describe 221 represents the initial rate of change, which describes what we would expect the salary to increase by per year. So we would expect that initially salaries are growing by 221,000 per year. Okay, now we notice that in 1 year it doesn't actually go up by that much. It only goes up by 201. That's why we have to think about this as the blast-off. If the rate of change were not affected by this negative 20t squared, then we would expect that the salaries would go up constantly by the 221,000. Okay, so we've really interpreted this value. We've interpreted this value. Now where does this come into play? Well, earlier we were talking about how when we take this number, the negative 20, and we double it, we multiply it by the exponent, negative 20 times 2 is negative 40. And we also mentioned how this number is the change in the rate of change. Okay, so if we looked at the changes in how much the raises were going up by, in other words, you had a raise of 201, a raise of 161, a raise of 81, a raise of 41, and then between years 5 and 6, a raise of $1,000. Well, over here I kind of have a cleaner table. So I noticed that the change in the salary over time is equal to a decrease of 40. So the salary raise is 40 less than it was the year before every year. Every year the salary increase is smaller and smaller. So I would be able to say that the amount of the raise players are getting is decreasing by $40,000 per year. That is, the raise in dollars per year is decreasing by 40 each year. Now graphically, we could provide our sketch by thinking about it in much the same way. Our starting value is 201, or 791. Our slope is initially really big of 201, but it begins to level out until they virtually get no raise